My name is Jimmy Yan. I'm with the InnoDB team. So today I'm going to talk about the monitoring system in InnoDB. And we have a short session, 45 minutes, so we will get all those things down in time. This is the agenda. So we briefly do an overview on what is the monitor system we're thinking about. And then we're going to do just one slide about what is the current monitoring system in InnoDB. Then we're going to talk about two new features which introduce incoming releases. One is the support for performance schema in InnoDB. And the other is one thing using called the metrics counter system in InnoDB. Then we'll do a summary. So monitoring system, I think it's very familiar term for a lot of people, especially when they're doing performance tuning. You must want to know something what's happening in a monitor, in a system, in a server particularly. And one thing I want to stress is that monitoring system is important for resource monitor, also as well as for the performance monitoring. And they have different audience. Some of those are for the developer, for the SQL developer, or for the actual programmer like us. And some of them are very important for DBAs. And when they have something configurable, they want to know whether the resource capacity is enough. And some of them, probably user want to know some information as well. They probably want to know how many rows they inserted during a time period. And the monitoring system we want to introduce, we want to make lightweight. And that will probably, we don't want ACID property for a monitor counter. Basically, we want to have statistics. We want to something know about the system, but we don't want to 100% accurate. So that it must be lightweight without much performance impact on the server itself. And the other thing is a lot of third-party use our monitoring system to make the server status visible. So we want to make the interface easy to access and easy to use. So current monitoring system in InnoDB, there are mainly three interfaces. One is the show engine InnoDB status, which gives you some status about locking, buffer pool, recovery transactions. And you also can create a InnoDB monitor tables. So it shows different information every few seconds. There are three types of monitor tables. The lock monitor, which gives you more information about the locking happening in the InnoDB. And there are table space monitor, which essentially gives you the space allocation information. And this so-called table monitor, which is basically metadata. You display all the indexes on particular table, as well as the foreign keys, columns, all those things. And they come with the last one is the status variable. There are about a little bit less than 40 status variable in InnoDB, for InnoDB, that give you more information about I/O, buffer count, all those information. So they are very fragmented. So it's not, at the beginning, it's not well organized. You need to get a particular information, you need to know where to get it. So that is the slide about what we're going to do in the next release, or next few release for the monitoring system. Basically, we want to do more monitoring, we want to give user, DBA, and developer more information. And this monitoring, we want to centralize it. We don't want to have user go different places to get different information. So we want to have one place to get all the information, if possible. And we want to make it extensible, which make it extensible is saying that it's easier for every feature developer to add new counters. So when they add a monitor counter or they add some monitoring system, they don't need to go through all the steps. They probably just do 1, 2, 3, and they can add up a new monitor counter. So that the interface to developer is easier. So that we have more monitoring in every feature that they need to develop. The fourth one is that we want to do easy query. MySQL InnoDB is a DBMS, so everything is supposed to be in tables. And we don't want to display in the error log with a bunch of text and people start to parsing it. So we want to display all the monitor data in tables. And the resource monitoring are also important, because although resources are abundant nowadays, you have large disk, you have large memory, but still it's a contention point. So DBA wants to know what's the optimal point, particularly for memory for disk. So we want to provide enough information about the resource as well as for the performance. So metrics table is being designed to achieve this. And we're going to talk about metrics table a bit in detail in the later session. So for event monitoring, we have the performance schema. And this is a good choice. So we want to switch to performance schema for the first part of the session. So what is performance schema? I think Peter has a session this morning about performance schema. And I just want to repeat some part of it here, just so that people not in that session know what is performance schema. It is a new feature in MySQL 5.5. And it's architected by Peter and developed by Mark. And it monitors low-level server events, such as mutex, RW log, read-write logs, and IOs. So this instrumentation actually gives you both the time, the elapsed time, as well as the counter for the events. So it gives you a lot of detailed information. And it exposes a SQL table. As we said, we like everything in tables. And it can be aggregated. You can average it. You can order by it. So what we do is that we have full support for performance schema in InnoDB 1.1. That is the upcoming InnoDB release coming with the MySQL 5.5. So what we have here is all the mutexes, total about 42 mutexes are instrumented. There are 10 RW logs being instrumented, 7 types of threads. There's one more thread we have for the InnoDB 1.1, which is the purge thread, introduced in this release. So it used to be 6 types of threads, but now we have 7 types of threads. For I/O, we have data logger and temp file information. So in the next few slides, I think you can get some information about what the performance schema is going to look like in InnoDB and what kind of statistics actually it gives to you. So to begin with, this so-called instance table. I think in performance schema, there are total about 18 tables. They're probably grouped into 4 groups. And then there are instance table, which gives you what mutex actually being instrumented. There are mutex instance table, there are RW lock instance table, as well as the IO instance table. So you just take a look at here for the mutex instance table, and I list all the mutex being instrumented as well as being created. So if you look at it, the number is 34. So I just say there are 42 mutex being instrumented, but some of those mutex are undefined. In particular, defined when only some debug flag is turned on, those mutex will be created. There are some mutex haven't been created, so there are total about 34 of them here. And just to notice, I use the distinct name for the table. The reason is being that there could be multiple instances for a particular mutex. So here's an example that rollback segment mutex. Now we have 128 of them. So that comes with another new feature that we talk about on Thursday in terms of the increased number of rollback segment. So now we have 128 of them. So we could have quite a bit instance for a particular mutex. For the same reason, there could be quite a bit buffer block mutex and other blocks. We have one pair for each 16K buffer. So easily for a 2 gig memory, you probably run into about 128K mutexes. So there are quite a mutexes, and if you just do a select, it gives you just endless output. And then the other thing is that for the mutex for the mutex instance, for the table, its default, it only supports 1,000 by default. So it doesn't make sense for us to turn on the instrumentation for mutex and other lock by default. So you probably won't see the block mutex other lock in the instrumentation. So again, the last bullet point is about if the mutex is not created, you won't be able to see it in the list. So that's about the instance table. And here's a process list table example that gives you all these threads running in the for InnoDB. So you see there are about 7 IO handler threads created by default. There's a lock timeout thread. There's a arrow monitor thread. And there's again another monitor thread which print out the monitor system or monitor information when you create a particular table, like a monitor table. And there are a mask thread. So this is a table this is a weights table, so-called. This weights table actually gives you something interesting. And it displays the last event happened for a particular thread. So if you just look at the last slide about the process list, there's a thread ID. So this thread ID is going to correspond to this particular thread ID here. And it could give you some interesting findings. For example, when we start an idle server, you look at it here, there's iOS mutex always being there. So what it's doing, there's nothing except just increment a counter for the iOS. And we're certainly going to get rid of this mutex probably sometime in the next release, because it does nothing, just protect a counter. And we can just make the counter atomic increment, and we can get rid of this mutex. So there's a kernel mutex, which is also used for protecting the lock timeout thread. So it does a lock timeout check, then it will obtain this kernel mutex. So this is like a background thread running. Every once in a while we get a mutex. So this is log sys mutex, which get a log sequence number, etc. So this is the wait current table, which gives you the what's happening right now, what's happening in the current time. And of course, if you have something blocked on the mutex, you'll probably be able to find it out from this table. You have a thread actually blocked on, suppose say kernel mutex. Then you will see it here and give you the line number and the file. So that's the nice thing about it. If you want to look at the history, the performance schema does give you limited, so-called limited history. And it's very detailed limited history. So there are two history tables that record each instrumented events. One is the event wait history, which contains about 10 events per thread. And the other contains about a bit more. It's about 10,000 events by default. So I think in next slide you probably can see some output from the query here. So this is a query that actually does a group by and order by, all those kind of sum of things. You can play with this particular table to see what happened in the last few seconds. So just to let everyone know this, even this is a history long table, you can maximize to 1 million rows, 1 million events, but it probably just gives you a few second history in a busy system. So you don't want to run a benchmark and you want to see something, get some conclusion from this history table, simply because it just gives you a few seconds information. So this is the output, the SQL query. So you look at it, you can see different events. And notice that their mutex appear in multiple places. So a mutex can be overloaded and can be happen in different places, and you exactly know which place is hot in the last operation. And also this table, you can truncate the table. It's like a normal table, although it's not a table, but you can just work on that. You can truncate it. So you will say, I want to wipe out the history. You can just say truncate table events with history log. So then you do some query and particular query and look at it, see what's happening there. And you can just do group by and see which place is the most hottest mutex in the whole query. So you can sum the time weights and you can construct. So how many times? So the time weights here, just to mention, it's picoseconds. So it's a very small number. Even looks like a lot. And you can also average it, certainly, because you have the construct, you have the sum. So if you want to say, well, history give you very limited history, you want to say, I want to everything, I want to have all the information. Then they come with the so-called summary table, which is give you aggregate information. So summary table, there are several kinds of summary table. The summary table can by event name. Summary table can by instance. So this is, if you look at it here, we clearly see the buffer pool mutex is a hot mutex. And interestingly, we have new features coming for this release, which actually split the buffer pool. If you're going to attend the performance session, we're going to talk about how we're going to split the buffer pool mutex, and such as you have more buffer pools, and the buffer pool mutex certainly no longer be a hot mutex. Kernel mutex, I think in this morning's session, Facebook guy saying the kernel mutex is being overloaded too much. I think yes, we already noticed that. It's not that easy to split them, but certainly we are working on that. So kernel mutex will eventually going to drop off because you see everybody starting almost every set action in the InnoDB involves some kernel mutex. And in background, even the deadlock check, another deadlock check, the timeout check, use a kernel mutex. Purge sys mutex. That's another hot one. And I think in this release, we're going to have also split the purge sys mutex. So there are the list of the hot mutex here, and certainly we're going to work one by one for us, for the InnoDB team, to actually resolve those hot mutex. So this is a few notes. So if you're going to work on the InnoDB code that you look at, you can actually exclude a certain mutex from the instrumentation. And again, the notes where you just talk about the mutex instance could be very large. It can exceed a few thousand K. And we certainly want to notice that. And each module of the InnoDB for those instrumentation can be turned off by changing a define. So this performance schema gives us a benefit. Actually, we can quantify the mutex and RW lock. So we can run some test benchmark and see how active, how many waves, how many contention we have for a particular mutex and RW lock. So this one thing we want to talk about, I think it is a natural question when people say, I have this nice thing, does it come with a cost? As of now, certainly it comes with a cost. So this is a simple DB2 test, which we had for the performance schema. And the setup is about regular setup. And we look at it, it's about 8% performance impact when turn all those mutex counters on. So certainly there are hundreds of mutex counters being turned on. If all turned off, not enabled, we barely see any impact. But as we speak now, we're certainly going to improve that. And certainly this number is going to be dropped in the next release of it is a lot of places can be optimized. And next slide is I took from previous slides. Just look at it and see more options you can do with this. You can turn on certain tables. You can turn off certain options. You can turn off the history table. You can disable all the mutex, disable all the RW locks. And you probably get less performance impact. And different tests give you different result. Some sysbench tests give you range from 5% to even sometimes 20% performance impact. So it does come with a cost, but we are working on that. So just in summary, to summarize, performance schema help us study and quantify low-level server events. It's a good tool for monitoring and development tuning, especially for mutex and RW logs. It does come with a cost, but we are working to minimize it. So in the next few slides, we're going to talk about the so-called InnoDB metrics table. That is a generic table which we're going to use for all the monitoring system. And it's an infrastructure work. So it's a work that wait for more developers to add more counters into it. And it just give you an infrastructure so that people can add the counters with ease. So currently it goes through the information schema table. So this is now persistent. This table information are now persistent. It's like a fake table. And the only interface for us for now available now is the information schema table. And it's very lightweight counter. And it doesn't have mutex protection. So most likely it will require the caller to synchronize, to provide synchronization protection. And certainly it comes with the control system to turn on and turn off and reset monitors. And monitor counter only starts when you actually turn it on. So it doesn't have any effect when you actually turn off the monitor counters. And they're used for a variety of areas. Some of them are for the resource counting, and some of them for the performance count. And it's especially important for DBAs because we probably are going to provide some limitation in terms of the cache, in terms of meta cache. Now the metadata cache all used in a buffer pool. And sometimes it goes to the open table, too many of open table, then you run out of the buffer cache. So we want to put a cap on that. And how do we know whether that cap will be enough? Then there will be a counter tells you how many tables will actually open, the time period. And currently, it doesn't have any measurable performance impact. So this is a look of what the table looks like. It has the matrix name. It has the what module it's supposed to belong to. And it has the values in stock. Also, you can reset the value and you get the value since reset. Also, it comes with the start time and stop time, and the status telling you whether the counter is running and what kind of counter it is. So by default, all the counters are turned off. So you want to study, you want to know something, you can turn on a particular counter. So this is what it looks like when you supply a SQL query. So suppose you want to know how many tables you open in the last query or last period. And you get values there. So the control system, we actually use session, we use global variable to control this monitor counters. There are about 4 control systems there, 4 global variables there. One is the InnoDB monitor counter on. There is the InnoDB monitor counter off. And you can do reset with InnoDB monitor counter reset. You want to reset all of them, the counter Then we call InnoDB reset count, reset all. So what you have here is that if you want to actually turn on a counter, you just say set global InnoDB monitor count on equal to the particular counter name. In this case, if you want to say turn on the server table open, you just say set global InnoDB counter on equal to server table open. And the counters are actually grouped into modules. So we have about 8 modules for now. We have module server, which is more for the metadata, like a table open is part of the module server module. And you have module lock, which gives you information how many deadlocks you have, how many lock timeouts you have in the last period. And for module buffer, this is more static information. It probably doesn't come with a time period. It just tell you how many buffer configured for the server and how many buffer, what the buffer activity is, how many buffer are being used, how many buffer are being evicted. And the module transaction give you how many open transactions is running and how many transactions has been committed, how many transactions have been rolled back. Similar for the log, how many log page being flushed. And page is more like I/O pile. Index, how many index split has happened. DML, how many rows being inserted, being deleted. So all the counters in a particular module, you can turn on, turn off by just specifying the module name to the control system. So you can say set global monitor count on equal to module server. So everything in the module server will be turned on. And it's very easy to add additional modules. So as a simple example, if I run a TPCC type of stress test and I want to see a lot of information, here's an example if I want to see how many rows get inserted and deleted in that test. So in the loading time, you turn it on, so you can look at it. It has about 24 million rows get inserted. If you do a select a count, for each of those tables, you add it up. That's exactly what the number is. And when you do a select this table again, you will see the number of reads become 24 million again as well. So that does all the scans. So this is just a simple example, more intuitive example. See what it can give you. So here's another same example. When you look at it on a TPCC type DB2 test, you just turn on all the modules. You turn on everything. Before that, you want to actually reset the counter. You can turn off the module DML, which is turned on. You want to reset everything, so everything comes to 0. Turn on everything, then you turn off everything after you're running the test. You take a look at it, so you will see some statistics in terms of how many tables open. So for all those transactions, only 141 times table open happened. InnoDB doesn't close table very often, so it doesn't close table. Once table is open, it stays in the memory cache. And there's a number of reads happening, a number of inserts, as well as the checkpoints, how many checkpoints has happened, how many flush has happened, a number of commits. So those are just part of the list you're going to see. We're just showing some list information there. So this counter gives you a lot of interesting information. And Eventually, some of them will need to become session specific. So it become particular to a thread. So we know a particular thread how many rows inserted for a user, not just global information. So you can, those global control system, global variable become session variable. So again, those will be further divided. Some of those information are server particular, server specific static information, like a buffer pool, how big the buffer pool you configure. Those are not actually counters. Some of them are global, and some of them could be very session thread specific. So you can get detailed information from those counters. So why this matrix table? Again, we said it's easy. We use a table, eventually a big table, to gather all the information and expose this interface to user. So it's easy to query, easy to aggregate. And it has very minimal performance impact. All the tests we run, we don't see any performance impact with those counters. And it's easy to extend. So we're not going to talk about how we're going to add a counter, but it's very easy to extend. Just two steps, you can add a counter. And it's a generic. So this is a table, an infrastructure for all kinds of information. So it's one-stop shop for all the monitoring information. So gradually we're going to go away from those create table interface. We're not going to see those interfaces will still be there, but we're not going to add additional information there. All the new counters will go through this matrix table. And all the existing status variable has entry in this particular matrix table. So all the information you want to get from the status variable, you can actually get from this table. So people will ask, this performance schema and matrix counter, are they in conflict? Are they doing the same stuff? So the answer is not. It's no. Performance schema is more for the event monitoring. It gives more information, very detailed information in terms of time, elapsed time, and the counters. But matrix table is more generic. It's very particular to InnoDB. Both try to avoid involved mutex. So both are now saying going to be 100% accurate. So there could be, in terms of control system, we don't have mutex protection either. So there could be some user turned it on, the other user turned it off, and there could be some conflicts. But we want to try to keep the performance impact as minimal. So we just consider this as tolerable because it just gives you enough statistics to give you a feel of the system, how system running, but we don't want to make it 100% accurate. But most of the time, it give you 95% of the time, give you enough good information. And for the matrix counter, most of them are protected by up-level mutex. So all those counters you added, about 99%, there are already some mutex in there. So there won't be any conflicts. So again, there's no measurable performance impact from matrix counter. Designed to be generic, simple, and cheap. So summary. So those are the information we're going to talk today. Is that matrix system table are likely to be our main interface for obtaining performance statistics and resource usage information. And in the probably next release, 5.6 release, this matrix system will be there. And there will be a lot more information being provided through this interface. Performance schema in InnoDB gives us a powerful tool to study events, mutex events, and other block, all those performance bottlenecks. And we are using that to improving our system. It's very awesome to improve. And here's some reference and more information to look at. Peter had a session this morning, and there's something about InnoDB counters tomorrow. And there's documents and also the blog in terms of performance schema. So that's all for today.